Greetings and welcome to today's educational program. In the webinar series of Preparing for Process Analysis, this is webinar number 4, Data Collection and Integrity by Sandy Furterer and Doug Wood. This is your moderator, Shobha Mittal with the ASQ Quality Management Division. And today we have the distinct pleasure of hearing from Sandy Furterer and Doug Wood. Please join me in welcoming them. Dr. Sandy Furterer is a professor of practice at the Ohio State University in the Department of Integrated Systems Engineering. She has applied Lean Six Sigma systems engineering and engineering management tools in healthcare, banking, retail, higher education, and other service industries, and achieved the level of vice president in several banking institutions. She has previously managed the Enterprise Performance Excellence Center in a healthcare system. Dr. Furterer received her PhD in Industrial Engineering with a specialization in Quality Engineering from the University of Central Florida in 2004. She received an MBA from Xavier University and a Bachelor's and a Master's of Science in Industrial and Systems Engineering from the Ohio State University. Dr. Furterer has 25 years and more of experience in business process and quality improvement. She is an ASQ certified manager of quality organizational excellence, a certified Six Sigma black belt, a certified quality engineer, a certified manager of quality operational excellence and ASQ fellow, and a certified Six Sigma master black belt. Dr. Furterer is an author or co-author of several academic journal articles, conference proceedings, and 9 reference textbooks on Lean Six Sigma, designed for Six Sigma, Lean systems, and systems engineering, including being the co-editor for the ASQ CQIA handbook and the ASQ CMQOE handbook, and the editor of the ASQ CQPA handbook. She also published a textbook on systems engineering, holistic life cycle architecture, modeling and design with real world application, CRC Press 2021. Moving on to Doug, Mr. Wood has worked over 40 years in the areas of cost of quality, office-based, root cause analysis, performance measurement. He has helped others with various ASQ certifications in quality auditing, management, and engineering. He has also taught audit, Lean Six Sigma, cost of quality, statistics, and failure modes and effects analysis. He has 4 ASQ certifications, CQE, CQA, SSBB, and CMQOE. He has 3 publications by ASQ Quality Press, the Certified Manager of Quality Organizational Excellence Handbook, 5th edition. It is also co-edited by Sandy. The Executive Guide to Understanding and Implementing Quality Cost Programs, Reduce Operating Expenses and Increase Revenue. Principles of Quality Costs, Financial Measures for Strategic Implementation of Quality Management, 4th edition. His firm, DC Wood Consulting LLC, has worked with clients in manufacturing, healthcare, and transactional businesses. His company website is www.dcwoodconsulting.com. And so, without further ado, it is my pleasure to introduce Sandy and Doug. Sandy and Doug, the floor is all yours.
Thank you, Shobha. I saw Doug smiling when there was something that came up as Xbox. Like that. All right. Well, it's very wonderful to be here this evening, and thank you, all of you participants, you wonderful webinar participants, for joining us. We're looking forward to some wonderful questions. This is a tough topic to condense in just about 45 minutes or so. So we're really looking for you to ask some questions to kind of direct us. And there's going to be a couple times when we're going to be asking for your input as well. So you can't snooze out there. You got to be paying attention. So glad to have you all here. So our objectives for our learning tonight is for us to continue our effort at helping to understand some quality and process improvement methods, and this being focused on data. We know that data is our lifeblood. We always say we follow in quality data-based, data-oriented quality methods and tools. And so data is at the core of what we do in quality. We can't do anything without measuring something and without presenting those results. So we're going to talk a little bit today on what is data integrity. We've got a nice term called data pedigree, which will describe what that is. I love that term. And then we're going to talk about different tools that you can use, whether you're planning your data, and that's where you get to a lot more of the measurement system analysis tools that we've used, a lot of database analysis tools from really the information systems folks. So it's not just us quality folks. We really need to engage the information systems folks, the IT folks as well. And then also how you collect data, how you validate that that data makes sense. And that's a lot of that is understanding your process. And then how do you analyze that data and present that data? Visualization has become really huge. We're just going to scratch the surface, but I hope, our hope is that you can get some good questions of what else you want to learn about these areas. So we're going to talk about what is data trustworthiness, what are some challenges, and we'll get some ideas from you, what you have all seen. What are some best practices? And then we're going to talk about the data analysis lifecycle, and we're going to talk about how we can improve data integrity. And again, each of these lifecycle phases that we're going to touch on. So I stole this, from Facebook. So I don't know who to attribute it to. You know, that's pretty common on Facebook. So I apologize for that. Although I do know that it was one of the professors that I worked with at University of Dayton, Yvonne Sun. She is a professor of biology. And so she had this, and I thought this was a really neat kind of graphic that really shows what we do with data. And so when you kind of start with data, it's like you've got Legos and you've just dumped the bin of Legos. You know that once you get them out of the box, they never go back to being organized like that. So, and they seem to grow for some reason. If you've had kids, you know that. And so then if you're like me, where you're a little OCD, you might put them into organized piles. So you're starting to sort that data, trying to make categories, trying to make sense out of the data. You might even count the data. So, you know, we've got the whole concept of attributes and categories. Is something good? Is something bad? Is it blue? Is it red? Is it yellow? And so then we can then start arranging things and maybe building and making sense out of our data, organizing it, analyzing it, and then up at the top, presenting it visually. That kind of looks like some kind of reverse Pareto chart, but a bar chart, almost looks like half of a normal distribution. And then I love this too, that we really need to understand what's going on with that data so that we can explain it with a story. And that's really understanding our process. And I'll give you a couple really good examples as we get into this a little bit further about why that's so important to understand the data. So why should we care? So I know that every one of you, the reason you selected this webinar was because you do care. This is becoming, data integrity is becoming so much more important. And when we don't analyze our data and measure our measurement system appropriately, we can run into a lot of problems with our data, and we can be making the wrong analysis and findings and judgments about our data. So it's becoming more and more critical, one, because we're getting a whole lot more data. We all see that. And we have to understand that data. There's almost no process that doesn't interact with some kind of information system. The examples I'm going to provide, a couple of them are going to be from healthcare systems, hospital systems and processes. And that's so important. They have just got inundated with data over the last several years. The Centers for Medicare and Medicaid had made some directives that you've got to get electronic medical systems. With that has also come a lot of business process management systems, a lot of transaction-based systems about their patients. So they've got lots of different systems interacting to connect to each other And we're now starting to get into what is called big data, where you've just got so much data that you can find even out there on the internet. So when you go and surf on the internet, how do you know where that data's been? How do you know who created that data? So these are all the elements about data integrity. And then we're going to also have a definition here for data pedigree. So this is the definition to start with for data integrity. This is probably pretty common if anybody's done any kind of database work or been involved in really understanding where your data comes from. You might have the IT folks come to you and say, you know, do you own this piece of data? Or who is going to own this piece of data? Who's going to be responsible for making sure this data is complete, that this data is consistent and accurate? And then you should be able to attribute it to a process, and someone needs to own that data. So where you need to understand where it's been. You need it to be legible, and it needs to be recorded when it happens, contemporaneously recorded. Example of this, I know they had a big push when I was in healthcare, process improvement, on getting physicians to sign consent forms and to sign orders when they gave the orders or when the consents were created with the patient. And yet they were constantly chasing some physicians to get that done after the fact because it might have been missed. And this was a lot of the times when it was still manual. Now things are getting easier because they're more electronic, and that has made things a lot easier. That you need to understand where's the original, what's the true copy, and what is the accuracy level. And they have a nice acronym called ALCOA. I think of aluminum when I look at that. But you know, when you think about your data and you download it from somewhere, you get it from your database, you get it through Tableau, you might pull it using some type of Python or something like that. And once you've done that, you don't know what somebody's going to do with that data. So you need to control that data up front. So you need to understand what people can do with that, because now they've got control, right, of your data. They can remove outliers if they want. And that's one thing. I presented parts of this presentation at the ASQ annual conference. And, you know, outliers, that was something that we really focused on. When do you remove outliers? And when do you change the original or true copy of the data? So data pedigree. So this is really understanding, you know, you think of pedigree as, you know, kind of what is your background, you know, kind of where did you come from? I came originally, my grandmother came from Poland. And so that kind of, you know, people say that and it's like, Polish, Poland. Oh, that kind of gives you the pedigree. Okay, you're Eastern European and all this kind of stuff. Well, that's the same thing about data. It's like, where's that data been? What's the technical meaning of that data? What process produced the data? There's really no data that doesn't have a process associated with it to connect that data to. And the importance of understanding that process and where the data comes from is so important. There was a great example. I probably had this marked down to talk about someplace else, but it really goes well with understanding your process. I was working with a process improvement team in the hospital to improve the flow in the emergency department. A lot of projects that focus on that because so many patients come through and it's such a chaotic environment and there are constantly capacity and flow issues, especially if those patients have to get admitted to the hospital. It needs to be that seamless integration between the emergency department and the inpatient floors. So we had been tracking, and they had been tracking a lot longer than the project, but we had been tracking for about 3 months into the project, the length of stay. And we identified, okay, the patient comes in, this was easy. They sign into a kiosk in the lobby, and now that starts tracking the patient coming in. And then it goes to when the patient physically leaves the hospital. Well, we thought that meant that was when they actually left the hospital, walked out. Well, we found that through the analysis of our data, that it was actually about 30 minutes longer because it was when the nurse got back to logging the patient out of the emergency department system, but they actually left on average about 30 minutes before that. It was just by the time the nurse got back to the database to say, click, they're gone, they had actually left 30 minutes earlier. So we were really disadvantaging ourselves with that length of stay with the data. So it's just an example of really knowing what your process is, what your data's gone through, who's deleted it, who's modified it. Do you let IT directly into the database to fix things or change things? You've got to think about all that from a pedigree. And this also talks about how you initially define the data. We talk about operational definitions. Doug's going to talk about that. So all of that is in this pedigree concept. So I think I've covered most of these. Just kind of look at my notes, see if there was going to be anything else. Oh, so I'm just going to ask a question. I'll let you kind of look at those concepts. They talk about the specific measurement process used. And if you can just kind of throw in the chat, how many of you recently have done a measurement system analysis on a process that is near and dear to them and that know the accuracy of that measurement process? And I'm going to stop for a second so I can see the chat. So go ahead and just enter in the chat how many of you have done a measurement system analysis and are very comfortable with a project near and dear to them. Just last week, Mark Donovan, good. Anybody else? Have they done a measurement system analysis to assess how accurate their data is, how accurate their measurement process is? Mark Paxson's done several. Anybody else? Once an internship, Ola has once in manufacturing, but not on a business process measurement. Several, yep, we had that mark. Okay, well, let's go on. Okay, so we had a webinar earlier. If you want to get the recording, go back to that. We did one on measurement system analysis, and it was actually talking about attribute agreement analysis. And so this is really important to assess, how good is your measurement system in collecting that data. And this goes a lot to pedigree and accuracy and integrity of your data. So that's one of the first things you want to do. I teach a course in design of experiments, and one of the student projects that really struck me that what they really were trying to get to was a data accuracy, not so much, it was kind of the variables that contributed to data accuracy. And I was thinking, the first thing to do would have been really to do a measurement system analysis and to make sure that their measurement system is really measuring what they think it is. And that goes with understanding the process before they can really understand what are the factors that are affecting that process. All right, so this is where, now that a few of you are used to entering some information in the chat, and I know some of you might be driving and really can't do that, or we have one person at the airport, might not be feasible. But if you can, look down this list and what have been your challenges with your data? Is it in collecting the data? Is it in relying on somebody else to collect that? Is it that I don't even have that data in a database to download it from Tableau or some type of database extraction tool? And so I have to collect data manually. Do I get a lot of duplicates? Do I get a lot of errors in my data? Do I even know what to collect? Can I transform that data? Do I have coding in there on my data that's not helpful and that nobody understands the data? So I'm going to again stop, and I'm going to let you put in some challenges that you faced, and you could have a lot of other challenges as well. That was just an initial list. So Leah says, collecting data is the most challenging aspect of data analysis. People don't always follow the process. Yep. If people even have a process, right? Relying on others to collect the data. Good. Defining the criteria to pull specific data types, right? Isn't there usually that gap between the people who set up the data in the database and put the terms or the labels on the data and us trying to figure out what that is? Used JIRH, HP Quality Center, and Zephyr tools for tracking software release cycles in the retail industry. Oh, that must have been for the other question. Okay. Waiting for others to generate data, and sometimes it feels like other work groups ask us to spend time collecting data that isn't relevant. We've seen that a lot where a group, their purpose in life is to send out these reports that nobody really uses anymore. Data is manual or in multiple systems that don't talk to each other, and they're called different things, right, Zach? Yeah. Waiting for others to generate data. Let's see, we said that. Manual, relying on manual or in multiple systems, don't talk to each other. Another one, relying on others. Human variable, absolutely. Getting access to the data. Yeah, sometimes, the data really should be owned by the users of that data, the people who create the data and need to use that data. Yet IT has such a tough clamp down on that data that they don't even let others get to it. So that's very true. So a lot of issues. Well, we're going to talk a little bit about the collections data. We're going to talk a little bit about the visualization and analysis of data, and a little bit on the planning as well. Okay, so data integrity strategy. So Doug, get ready. You're going to be coming up here next. So this is a tool that is really almost given to you as a list of keywords that you can search a lot more on after the webinar ends, because these are whole webinars in and of themselves. The whole concept of designing that data, defining what data needs to be collected, what are the terms going to be operationally defined as, who's going to need to read that data, view that data, who's going to need to update the data, who can delete that data. These are all the elements of best practice in data design. We've talked a little bit about measurement system analysis. I kind of get jealous of people in manufacturing who actually have physical gauges that they can measure their data with, and their actual, variable continuous data that they're collecting. But think about the measurement system analysis of people who are putting things into categories. Was this good? I remember when I was watching a plastic extrusion cup process, and they had a couple quality checks at the end of the line. One was weighing, except that they stacked 25 cups because their scales weren't precise enough to weigh just one cup. So they thought, well, they're trying to get an assessment of how much material is in here, and they're going to weigh 25 cups together. They also would squeeze the cup to see how brittle it was, and then they would look at the color of the cup. So there were a lot of visual assessments of that quality from people who'd been on that line forever, but there could have been new people as well. And how do you get that alignment between defining whether something's good or bad, pass or fail, in putting into categories? We've got a lot of different statistical software applications. My fave, I love Minitab, but I've used SAS and SPSS before. R, I know, is getting very popular, as well as JMP. Data visualization tools, those are more things that will pull the data and then organize that data into something visual for us. And Python is also becoming super, super popular. But requires some coding and scripting and those types of things, but very powerful, especially in getting that big data. And then looking at statistical tests and making sure that you're performing the right statistical tests on the kind of data that you have. Tracing your data. A lot of the FDA-oriented medical device types of Companies have to make sure that they can trace the data all the way back to production, and possibly design. So there's just a lot of things in controlling our data that we also have to think about. So we're not going to get to cover all of this, but these, just gives you an appreciation of all of the elements that go into our data, that we as quality professionals are going to need to learn more and more about. All right, now Doug's going to jump into the data analysis lifecycle, and just let me know when you want the slides progress there, Doug.
Okay, I will do that. So here is a handy six-sided diagram to understand what the data analysis lifecycle consists of. We're going to go through all 6 of these steps, not in a lot of detail. Again, this is a short webinar, so we're not going to cover all of this in extreme detail, but this should give you a sense of where we're going. Next. So it all begins with planning. You need to use the best practices in data design we've been talking about here. Sandy's been giving us a great overview, including good operational definitions. That's data about data. Sometimes that's called metadata. This is making sure that you've described what the data means. Where does it come from? What are the different values, and how do you classify them? There's information, information class diagrams is one technique. Data modeling is a technique that can be used. And a data dictionary basically just says, here's all the fields and what each of them mean, okay? Now, don't forget the security aspect of design. Who will have permission to create, to view, to update, or delete data? That's all part of best practices in order to have a good plan. Next. So here's a diagram, okay, a short example that might help us understand more how these best practices fit together. In an interventional radiology healthcare example, we begin with a process flow diagram. Well, of course we do, right? This allows us to look at where the metrics fall in relation to other functional steps. This is part of understanding the process that Sandy was talking about. In this example, process metrics appear to be a tiny portion of the process. It's just that one that's got the circle around it. Poor data design, however, can create process metric issues that won't appear until later. Next. Here you can see some definitions of the metrics used in our example. Note that the units are indicated on the metric. The operational definitions on this slide are kept short so you can read it, but mostly you're going to have longer ones when you do your own operational definitions. Some operational definitions can be an entire page. It just depends on how complex the information is it's coming from. It's important to understand that the language used in your operational definition makes sense to those who use the metric. They need to know what you're saying. Okay, next one, please. Now, we know that no plan survives contact with the enemy or with reality, but we still need to plan. So having a project charter can save time later. On this slide, CTS stands for critical to satisfaction. Our data collection plan and operational definitions need to consider what our objectives are. Where do we want to go with this data? Next. So you can put the project name or the title of your project on the charter. You want to make sure you avoid jumping to conclusions or solutions, putting solutions into your project charter. Generally, you don't know where this is going. The data will lead you there. The problem statement should be as specific as possible to describe what is happening today. Why is this a problem? What impact does it have on the organization? The goal should be created and agreed to by the team and the project sponsor. Hopefully the goals will be achievable in a reasonable period of time, 120 days, 160 days. Remember that your goals need to be SMART. There's another acronym like ALCOA earlier. SMART can be defined as specific, measurable, achievable, rational, and time-bound. When we say achievable, we mean something might require effort, but it's not impossible. So there's some judgment necessary when you're building these things. Next. The operational definition will guide what will be measured and how it will be measured. Now, there's no single one way to write an operational definition. It's basically what your subject matter experts will agree to on a specific purpose. And so you have the subject matter experts involved in what exactly is it? How do we define this? The goal is that any two subject matter experts using the operational definition will be measuring data in the same way. That doing it any other way is just chaos. Next, please. Now, then we move on to step 2, create. And we're looking at activities that enable data collection. Sometimes your information already exists in a database. Using existing data is always a good idea, provided it's appropriate. Existing data sets may have gaps, and these missing data elements will need to be filled for our project to be successful. This would involve collecting additional data. I have yet to see an existing data set, open it, look at it, and find that it's good. Have any of how many data sets do you open that are perfect? You can put that in the chat. I just don't think that exists. Okay. So we
A lot of nuns there.
Yeah. We have to remember that data is often collected automatically, and bad data gets mixed in. One of the more important things in your data stream is to make sure that there's a human looking at that data as it goes in so that you can catch gaps as they happen. And don't forget to go and observe the processes and understand them before you do data collection. What exactly is this process doing? Now, one question. What's the definition of good? Good is satisfactory for use. Okay, and your subject matter experts can help you there. Next. So many of these data collection tools can be studied. See, here we're on step 3. Work sampling may be the one you've not used. Work sampling means you're going to collect what percent of activities are performed via observation of workers and recording the activity they're currently doing on a randomly generated schedule. Time study is one that's often used. Time study is a technique. You use a stopwatch and you measure something's speed. It collects times for a process that's broken down into activity elements. Time study should be used on a repeatable, documented process. And it records a representative sample of the activities. Job shadowing or observations oftentimes collects a lot of attribute data. You're observing the work, you're shadowing the job being performed, and you're trying to better understand the activities and all the factors that link together. Gaining a representative sample of extracted data considers seasonality, that things shift over time. It considers what is the current process that's being performed. It considers how large is the data set going to be? How much data do I really need to have? And what software can you use to extract, analyze, and visualize the data? You also have to validate the data. And one more thing you need to consider. You need to consider that the people collecting the data must be calibrated. They need to know what they're doing and why they're doing it. Or they're going to all do it differently. And then you'll just get a mess of numbers, not data. Next slide. So in step 4, or validation, you need to make sure that your data is sound. When validating electronic data, some additional best practices should be considered. First of all, check for all the records being complete. Check for missing values or gaps, zeroed out records. You can create a time series plot or graph or histogram or all three. This helps you see the data, what's the shape of the data, what's going on with it. Look for data that does not fit the norm, what you think it should look like. Review subsets of the data to see if each of them appears similar. Do like processes give similar results? If not, why not? See, this is all about understanding the processes that the data is coming from. In terms of data types, is the data type consistent? For example, is it text entry when numeric data is expected. That can create real problems when you're doing analysis later on. Next. Data reliability refers to the consistency of the data over time across data types and across different operators measuring the data. Validity is the extent to which the scores from a measure represent the variable that they're supposed to represent. Next. Okay, the next one is step 5. We begin to do our data analysis on our valid data because we're sure it's good stuff now. We've already seen a flow chart. A value stream map is just a version of that. The value stream map helps us see how various steps relate to one another, and it often includes some measured numbers to determine value added time and non-value added steps. Histograms are another tool that are useful for identifying the shape of the curve. We're all familiar with the normal distribution. Some call it the bell curve. It can show whether or not your data is skewed right or left. It can show whether or not you have two different processes operating. Having two modes or two humps in your data. Again, if you have two humps, you've got mixed data. You need to figure out what each one represents. You also have to see, do you have any outliers? Sandy mentioned that earlier. An outlier is a value that is away from the rest of them by some distance. It lies in an abnormal distance from other values in a random sample. In this sense, the definition leaves it up to the analyst. It's kind of a consensus process to decide what will be considered abnormal. Before abnormal observations can be singled out, it's necessary to characterize what a normal operation is. Then you can start to say, well, that one is abnormal because you need to be careful, though, when you start getting data that has a few outliers. Those might be new values. Something might have shifted in the process, so you don't just want to throw them out. Another data analysis tool is a simple bar chart. These can illustrate shifts in the data where a table might obscure what's going on. Next.
Think I'm jumping back in, Doug?
Yes.
Okay.
This is yours.
Yeah, so there's just a few more slides on this interventional radiology process improvement. And this, just to give a little background, this was a project that really came from the radiologists, the physicians who were working in the interventional radiology. And they were uncomfortable with the data, that it really wasn't giving them what they needed to improve the process. And what they found when we started getting into this, and this was led by the physician and the nurse manager, and then we had other specialists and nurses within the department that were working on this. So they really understood that process. And what I've noticed since I didn't have a healthcare background before I started process improvement in the hospitals, I could, like Doug said, give them run charts and histograms and see the outliers and know that something was changing with statistical process control. But I wasn't able to tie it back to the process and to understand where that data was coming from a process perspective. So that's why it's always best to have those subject matter experts that understand the process, because as soon as you say, hey, oh, this is a little weird, they'll say, well, that's this or that's that. And that's how we discovered that issue with our data for length of stay in the emergency department. And this is an example of where we started looking at the length of stay, and we found that there were two different fields for starting a case and two different fields that could be entered into the database for ending a case. And the unlucky aspect of the process was that they had recently had some type of upgrade to the software, and usually the screen changed colors or the field on the screen changed colors when somebody had already entered that field, and somehow that got lost when they did a software upgrade. So we were going back in time. We were we were finishing a case before we started it sometimes. So we knew that there was something definitely happening with the data. We also knew that there was also a lot of missing data. I think about 20% of the data was missing because people didn't always click when the case started and when it ended and when it went through different steps of the process. So if you aren't even getting all of the data, how do you know that you're really observing what the process is really doing? So that was the first thing we did. Then once we got a handle and we started getting cleaner data, we wanted to analyze what was then going on. Were we getting improvement? And that's where you have a two proportion test that comes in. We were able to understand the percent of the patients that were starting, or the percent of the cases that were starting on time. The patients were getting in the room on time. And so we had two samples. One was the before we had improvements, and one was after. So we had 48% versus 61. And you say, hey, that's definitely an improvement, but we want to make sure. I know I've seen lots of improvements with the mean, but then the standard deviation or the variance was so high that it wasn't statistically significant, even though it looked like it was. But that's why you always got to run your tests. So a two proportion test, this is an example of that. And you can get a p-value. And if the p-value, your null hypothesis is that those proportions are equal, versus the alternative is no, there's been a change in our process, they're not equal. And if our p-value is below typically our 5%, 0.05 level of 95% confidence, and we reject our null hypothesis. So there was a change in this process from a positive perspective. So always important to use your test, your statistical test. Now let's move on to an example of data visualization. So we had done this in the emergency department when I was working on that project. And this was an example of being able to see visualize exactly where the patient was at process. And what they did in the emergency.
Sandy, make sure that your microphone is not unplugging because your voice is cutting out a little bit.
Oh, okay. Sorry about that. I'll get a little closer. So what this showed was for each bed, you could see exactly, pull from the database where the patient was in the process. And so as you click those different fields in the database, you can say, okay, the patients received their lab results, or if it's not clicked, they haven't. And then the computer can automatically, because that's what computers do well, is to make these calculations and send it to us and show us that, hey, we've been waiting for lab results for about 30 minutes. And so you can put those alerts in, define those, and you can display this where everybody can see it so that everybody can help to get the patient back on schedule. Some other data visualization tools. I personally like the kind of traditional, I love Pareto charts to identify, in this case, where were the delays in the process. Doug talked about run charts and control charts. Those are so valuable to be able to see whether our process is stable or whether it has improved or whether there's some assignable cause that's occurring, where it's going over time. And then there's also a radar chart, which to me, I think sometimes they're a little bit hard to read because you really got to look at them for a while. This one shows the number of studies in different categories. So just to wrap it up, we hope that you have been able to glean a little bit of perhaps some of the challenges, some of the best practice areas that you could focus on, understanding the importance of the overall data analysis life cycle, and how important it is to really have different tools to focus on, whether you're planning data, you're creating your data, whether you're collecting, whether you're validating it, analyzing it, or visualizing it. And so a lot of times we're really excited to understand our data and go right to that visualization. But I hope that you all have an appreciation that there's a lot of other methods and tools and a lot of steps before you get to that really fun stuff where you can show your charts to everyone and throw those into your PowerPoint. Here are our references. Now Shobha is going to.
Okay. You're cutting out again, Sandy, a little bit.
Okay. Okay, thank you. And turning it over to Shobha.
Okay, Shobha, what questions do we have? I can see one here. One of the Q&A.
Okay, sorry, I was muted. So I'll read the question.
Sure.
So is there a difference between data integrity and data quality?
Data quality is general. That's kind of a fuzzy description. Data integrity, we try to define it here with some more precision. The quality of data, that word's just a catch-all for bad data. What do you think, Sandy?
Yeah, I definitely agree with that. I think the integrity concept really ties it to activities and tools that you can use to improve the integrity of the data. I think it just defines those elements that we talked about, the Alcoa. What are the elements that we need to focus on? Whereas quality, I agree with that. It can be very vague. I mean, you can define it operationally, so you can then say, what is the quality of my data if I'm measuring it against some operational definitions? That's fine. But I think that the data integrity definition takes it further to the activities, tying it to activities and tools.
Mm-hmm.
Thank you. Moving on. Would you recommend a dry run of data collection to identify and fix bugs? If not, why not? If
Oh,
so,
yes.
what would you recommend be considered in dry run? Example, questions to ask, duration, simulating failures such as process outages.
Absolutely, dry run. Absolutely. That's part of calibrating the humans. You need to set it up and try it. And the people will do it. And then you look at what they write down, and that'll tell you whether they're doing it right. Then you have to come back again and retrain them. Sandy?
Yeah, I agree with you. I always think that we should, well, I always start with the process map and almost anything after we've done the planning, the defining of our project and objectives. But then, understanding the process is really critical. But then collecting that data and just really doing some initial histograms, doing a little bit of analysis on it, your means and your standard deviations, and then showing it to the process experts, because they're gonna tell us whether this data is valid or not. They'll know it immediately. And so I think that's what it helps. And then we can get an assessment of how much data is missing, how poor is our data, what are the types of errors in the data. And so I definitely think piloting, kind of the concept of piloting our improvements on a smaller basis is certainly true with our data as well.
Okay, our next question is, do you think data analysis skills will be more important in the future? As automation does more work, do you think people will spend more time doing data analysis?
Oh, yes, I definitely think so. I think you're starting to see so much more of it. The whole digital transformation, I like to call it digital transformation versus the quality or industry 4.0. I think it's as people bring in more information systems and try to connect them. We had several instances of these are the challenges when we have multiple systems that we can't connect and we don't know how the data connects and how do we make sense of that? I think we're going to see so much more of that as we try to automate so many more processes.
I also think that the term data scientist or data analytics, we're going to start to see different versions and flavors of that depending. The whole industry of data analysis, it will become specialized, and we're going to have a lot of different job titles in there.
Next question. Do we in ASQ have recommended methods for best practices associated with interviews, especially around plan, create, conduct interviews, collect, and validate.
Oh, can I answer this one?
Sure.
Yeah, it's called auditing. ASQ has a lot of material on conducting audits, which is essentially what you're talking about when you're interviewing people. You're trying to find out what they know, what they do, what they think. And auditors do that all the time. And if you look at any of the good materials ASQ has on auditing, it's going to talk about the planning process to do a good job to collect the correct information.
Okay. Let me go to the one. What is your favorite statistical software to use?
I think I mentioned mine's Minitab, but it depends what you're doing. SPSS, I've used quite a bit too. It's fantastic at attribute survey analysis. That's fantastic. I've talked with Minitab about can you analyze survey data more than one question at a time in Minitab the way it comes out of the box, and you can't. You could write some macros is what they told me, but SPSS is where you want to be if you're doing any kind of survey analysis. But there's going to be different aspects that, and it depends how people get used to it too.
Yeah. If you're one of the tools that I find absolutely essential, honestly, it's Excel. Everybody has it, and you can use Excel to sort your data. I mean, the other tools, they all say we've got data sorting tools built in, but I don't think any of them are as handy or as widespread as Excel is. So Excel helps you get it right. Then you move it to the analysis program. And Sandy mentioned SPSS, which comes out of the social science side of research. And so that's why it's got some of those features. Minitab is more oriented around data analysis. And of course, if you can't afford Minitab, there are some pretty good add-ins to Excel that are cheap. They work, okay? They're just a little bit slower than Minitab might be. Okay? Did we answer that, I think?
Yeah, and there was also, I wanted to bring up the question in the chat. In what part of process workflow are process metrics most valuable, middle or at the end or both? I would say everywhere. I would say definitely define what you need to understand and start with your critical to quality or critical to satisfaction characteristics. That will lead you to what process metrics you need.
That kind of orients to look at your strategy. Okay. Use the strategy of your organization to guide what's critical. Okay.
Next question is, one of the issues I've encountered when assessing data outliers is how to treat precision versus bias, especially when the data is limited. What I've seen is that data uncertainties are not being identified consistently or treated in a statistical analysis appropriately.
It's kind of a sophisticated question there. I'll let Professor Sandy talk about that first.
So when I think of precision, I think of the measurement instrument itself. And so my example about the cups was that the way that I found out, we're implementing statistical process control on the line. And the way I found out that the scales weren't precise enough to collect the weight of a cup was that I had started with a cake, and I was kicking the project off, and I brought a cake in. And so I was going to say, well, everybody can cut a piece of cake and we'll measure this cake and we'll weigh it on the scales that they use. And cake, I love cake. It was chocolate cake with white frosting. And it had, man, I guess I'm getting hungry now. And everybody started weighing them, and they were different sizes, visibly different sizes, because Doug's gonna take this huge piece and I'll be polite and take a small one, but then I'll go back for seconds, But and they all weighed the same. So that's a precision issue, I believe. And then from a bias perspective. That's a lot of your actual measurement system. Are you introducing bias in the way that you're measuring something? And that's not so much, I think, the instrument. I think that's more about how it's being done. Like Doug said, calibrating the people that are measuring things.
Okay, I'm going to
Hopefully.
take one final question because we are at 6:58.
Okay.
More on dry run. Any guidance on how long to run the dry run, event-based duration or real-time duration?
I think you kind of know when the dry run is done, when you aren't finding any more issues, when you've resolved a lot of those issues. Some can take a month, some can take 6 months. I mean, it's really if you have the right people in the room that really understand that data and the process together.
Yeah, I recall doing dry runs when I worked at Kellogg's, and we were attempting to measure the density of the cereal. Believe it or not, the density is the critical thing. You want to get the right amount in the box, okay? And it crumbles as you process it. And so we would take density measurements, a 1 quart can weighed on a scale, but we had to do it standing in the rafters of the building. And so you'd be up there with this scoop in the rafters of the building and a scale. And they had to train all the operators because we had to do 10 points of selection at the same time to get, contemporaneous data. And so everybody had to learn how to scoop, how to put the flakes in the can, how to not shake it when there was a skill set there. And so we would practice and practice and practice. And the experts who were training us, me included, they would just observe us and watch us. And they would look for excessive variability. It took different amounts of time for different people. And some people never got it. Okay. And they were basically wiped, no, you're not going to collect data. So.
All right, thank you, Sandy and Doug. I'm going to stop recording now and do want to